Hey guys, what's up? This is Prachurja and let's continue with our lectures on laws of motion. So we have discussed about the first law of motion and let's move on with the second law of motion. Now the second law of motion is one of the most important laws ever discovered in physics and it is called the real law of motion. It states that the acceleration of an object is directly proportional to the net force exerted upon it and inversely proportional to its mass. Now let's write it in a formula. Let's denote acceleration as A and force as F and the weight of the body as M. Let's talk about this body here. Now we know that these two things here are vector quantities, but we first of all let us deal with only the magnitude of the scalar quantities. So it is given that the acceleration is directly proportional to the force, and the second point is the acceleration is directly proportional to 1 upon mass, or it is inversely proportional to the mass. Now let us combine these two, and by combining these two I think I get acceleration is proportional to F by m, and when we remove the proportionality constant we introduce we remove the proportionality symbol, we introduce a proportionality constant, and thus we get A is equal to kf by m, and experimentally it has been determined that k is equal to 1 in the m case unit or the SI unit. So we thus get that let's write it here, F is equal to ma. Now let us come back to the vector analysis of this, and we see that F is a vector, acceleration is a vector, while as m is a scalar, mass is always a scalar quantity. So we can say that this can be of the form that a vector is equal to some scalar times another vector. So I can directly put the vector sign above it and say that f vector is equal to ma vector. This is the real law of motion and the most famous equation, f is equal to ma. Now let us see that how it is applicable in the real world, because similar not only formula is important for us, but how does it work is also important for us. Let's move on. Let's say we have three objects like these. One is a very heavy one is a little lighter and comparatively lighter than the first one, and the last one is very light. We have a force F vector acting on it, and it is equal in direction as well as magnitude on all the three objects. So by common sense or by general experience we have that when we push a heavy box, it tends to move slowly or it sometimes never moves, but that is the case when there is friction beneath it. Let's say that this earth here is not opposing the movement of the body, so when we push it, it still we feel that it is not going forward as it should have been. The same way if a light object or a ball is thrown. Now let's move on to the middle box. When the middle box is pushed like this, it moves a little more faster than the first one, or it moves a little more forward than the first one. And if we consider the lightest one, it will easily move without any restriction or something. So we see that the statement that acceleration is inversely proportional to 1 upon m seems correct, because the acceleration denotes that how fast it is moving or how forward it is going. So if the mass is high, then acceleration has to go down, and it is happening in the first case. In the first case the mass is very high, so the acceleration has gone down and it is not moving fast. whereas in this case the mass is going down but the acceleration is increasing. So it is also a right statement that acceleration inversely proportional to 1 upon m. So the second part of the statement has been proved using common experience or common sense. Let us prove the first part also using common experiences. We also have now three objects which have the same mass. Let's say the mass is m. Okay, now we are applying forces on these. This is say f1 vector, this is f2 vector, and this one at the bottom most is f3 vector. Now I've tried to make the arrows bigger and smaller so that we can see what is the magnitude of these. We see that the first one has a smaller magnitude, f2 has a comparatively higher magnitude, and f3 has the highest value. Now by common experience, again we come back to common experience so we can explain this thing, that when we push the first one, it will tend to move a little slower, or it will not move so much forward. Let's say we have a box and we just push it with one finger, so that is the force we are talking about. It will not move so much, but it will move by another 1 centimeter or 2 centimeter. Now let us talk about the second one. Okay, now let us suppose that there is the same box there and I push it with the palm of my right hand. So it will move a little more further because I pushed it with more force. So that it will move more faster. So the more the force, the more it moves forward. Now let us talk about the last one, in which I push it with both of my hands, the palm of both my hands. So now it will move more forward, more faster. So it can be said that when the force is increasing, the acceleration is increasing, and somehow it comes out that the acceleration is directly proportional to the force applied. So by common experiences we can say that if the acceleration is increasing, if the mass is increasing, then the acceleration has to decrease, and somehow it comes out that it is inversely proportional. And if we talk about the force, then we see that when the force is increasing, the acceleration is also increasing. So the same way it happens. So when we combine these two and we put a proportionality constant, and somehow using experiment the proportionality constant come out to be 1, it leads to one of the greatest formulas, that is F is equal to ma. F is equal to ma. Now this is the real force equation. Each force, there is no force in the world which does not obey this equation. There may be forces like the nuclear forces, which are not the real type of forces but are microscopic forces. They may not follow this in a high detail but have relativistic effects on these. So this may not be the prime formula for this, but every other object in the macroscopic world follows this formula. So this is a very important formula and a very important law called it's got the first second law of motion and the real law of motion. So that's end of this lecture, because this is a very important topic and need to be retained in mind, because after we study the second level of kinematic like projectiles and other things, it's very important that we get into this. So thank you guys. Just revise this topic from any of book of your choice, and if you have any questions, post it in your comments and let me know it. Thank you.